got Alex. Can you see my lovely picture over here? Alex has a mass of 62 kilograms. There he is. I have a before and an after picture. Remember when we were doing impulse and we had a before and after picture? Sometimes with these conservation and momentum problems, you'll already be given a before and after picture. So here's before. There's Alex. We'll label him. Whoops, not with that marker. Let's make that thinner. Okay, here's Alex. Okay, and there's the cart. He's going negative 4.5. Notice how he's going this way. That's negative. And he's got a mass of 62 kilograms. Alex, who has a mass of 62 kilograms, runs down the aisle towards a 93 kilogram cart full of groceries. That's a really heavy cart full of groceries. His velocity is negative 4.5 meters per second. When he gets to the cart, he jumps on and rolls with the cart down the aisle. Okay, so here they are rolling. We'll give them some motion whooshies. Okay, we want to figure out how fast. Well, eventually we're going to figure out how fast they're going down the aisle, okay? So we're going to answer these questions in order. They're going to walk us through getting to that answer, okay? So we'll start over here. Alex's momentum before the collision, okay? Alex's momentum before the collision, let's see, momentum before the collision, that's going to be the P equals mv equation, because I know his mass and I know his velocity. His mass is 62 and his velocity is negative 4.5. That negative is a direction, so I'm just going to copy it down, and then when I plug it into my calculator, I'm going to do 62 times 4.5, and I'm going to get 279 kilogram meters per second. So that's just the kilograms times the meters per second on there, okay? That is from lesson 3. That's not even a new kind of equation there. Okay, the cart's momentum before the collision. Now, I don't have to write all this down. These don't have all the directions on what I need to include in my answer, but I can think this one through. How fast is the grocery cart going? It's just sitting there in the aisle. Okay, it's just sitting in the aisle. I can write it down. P cart equals M cart V cart. The cart is 93, but it's going 0, and anything times 0 is still 0. So it's 0 kilogram meters per second. If all you wrote was that 0 equals kilogram meters per, or 0 kilogram meters per second, you would still get the credit for that question, okay? If you know something isn't moving and you just write 0 kilogram meters per second, you can do that. All right, so the total momentum before, this is where I've got to use that P total equals P1 plus P2 plus the rest of them. And so that's the equation I'm going to use here. But I've just got Alex in the cart, so I'm just going to write Alex in the cart, which is the negative 279 plus 0. The negatives are really important here because if you have objects going in opposite directions, their momentums are not going to add, they're going to subtract. And so in this case, I'm going to end up with negative 279. If the cart were moving in the opposite direction and I had like negative 279 and plus 300, then I would have like a smaller number, right? And what is that? Well, that would be like 21, okay? So it's really important to make sure you have those different little pieces. All right, so the total momentum after the system, well, I don't have any idea how fast it's moving, so I can't use P equals M times V. I have to use something else. Well, I happen to know, this is where that law of conservation of momentum, sometimes when I'm feeling really lazy, I write conservation of momentum, okay? And then I know that the before momentum is the same as the after momentum. So it has to be the same. And I can just copy that number down here. I don't even have to write the equation. I can just know that they're the same. All right, now this question is asking me to find the total mass, okay, because they're stuck together in the end, right? The total mass means they're sharing that 275 or 279 kilogram meters per second of momentum. So I'm just going to add their masses together. Alex and cart, they're now stuck together. So 62 and 93 gives me 159, okay? So when I have to find the velocity of the cart after, there's the equation right here. Okay, so I just need to copy that one down right here. I'm doing the cart, notice how I put C plus A, because now they're stuck together. Cart and Alex, so the momentum of the cart and Alex, which is the after momentum, which I just found right over here. Whoops, that is erasing stuff. I just want to highlight stuff. There we go. That's what's going to go on the top over here. And then I just have to plug that into my calculator, and it gives me a decimal with a whole bunch of other numbers. So it's negative 1.8 and some stuff. I rounded, okay? You do not have to write down everything that comes out of your calculator, but this is how fast they're going. So they're going to continue in the direction that Alex was going, which makes sense, right? Why would they go the other way? Okay, they're going to continue in the direction that Alex was going, but they're going to go a little bit slower because Alex and the cart have more mass, so they're going to have to slow down now that Alex is there because there's more mass, okay? More mass means less velocity if you have the same momentum. Okay, so that's it. That's all we're doing with the conservation of momentum. These questions might require a bit of thought. If you need help with that, make sure you ask your teacher for some help. Thanks for watching.